Welcome aboard. Here we go. So, in section 3.2, the surface areas, I'm talking to the computer because I'm recording it. So. Working with the surface area of a cone. Ice cream cone turned upside down, right? That's what we're talking about. Now, circular base, and then a triangular kind of like it's a teepee, right? Cone's like a pyramid, but it has a circular base. The net of a cone is a sector of a large circle and the circular base of the cone. Meaning if you took out the canvas of the teepee, it's actually curved when you lay it flat, isn't it? Right? The surface area of the lateral base of the cone, not including the base, can be calculated using this formula. Here, and I'll make it big. Where R is the radius of the circle base, S is the slant height of the lateral face. So this is S. You know, like if you measured the pole length right to the very tip, not the part that's sticking out. Anyways, the actual height is from the center up to the top. And the radius is that circle's base, right? So that's the three measurements. We need to know the difference. We actually don't need the height for the area of the tarp, little part. The area of the cone, lateral area of the cone is pi, so 3.14, radius in S. I'm writing it on here so it's easier to see, but you guys have it on your paper, right? So let's just try this. Find the surface area of a cone. It has a radius of 12 feet. Slant height, 15 feet. I want to draw this first. Draw it. So that's what we're talking about. Oh, geez, tripping on that cord. I have a lawsuit on my own hands. I'll sue myself. Cordless computer, eh? That's right. Many a cord. So, find the surface area of the cone that has a radius of 12 feet and a height, slant height, that's different than the height, of 15 feet. So, just draw like this. The radius is 12. The slant height, that's the height from here to here. I'm going to make that look like a mess again. Is 15. I should put 15 feet. That's all I needed there, right? I just want you to understand what they've given you. This problem. They, meaning me, what I've written down. Pardon? Oh, as a net. I see what you're saying. You could, but I don't think that helps you. I just wanted you to draw it like this so that you can see. You know what I'm saying? See what they do. Because if you do, it's just a portion of a circle. And it's kind of screwy. I don't think it's worth drawing out. I'm not even going to look up if they do or not. I don't care. It's my class, right? Find the area of the base. How do you find the area of a circle? Because that's the base, right? Even though it looks like an oval here. We want the area of that circle there. So, I'm going to draw the bird's eye view of that circle, right? You don't need to do this, but I'm trying to get you to understand it here. That's 12 feet. The only measurement you need for the area of your base. So, let's go for this. Circular base, you know how that's pi r squared. That means 3.14. Oh, why am I doing this? I'll let you guys write it down. And then I'll tune in when you guys have done that. Brandon, are you with us on this page? Go. Get up there, eh? Tell me what to write. Okay, 3.14 times 12. Okay. Is it just 12? Not. Squared. 12 squared means 12 times 12. You're going to hit the square button on your calculator, or I'll just put 12 times 12 on. Different than times 2. It's not times 2. You have a calculator with the square button? You might be right. 144 times 3. Yeah. So I know it's going to be, is it 400-ish you said? Yeah. 400? Yeah. 450-ish. 3.14 times 12 squared. Yeah, 452.16. I think you said that, didn't you? I don't really care about the 1/6, but that's feet squared. How big's a small 2-bedroom house? Square footage. You guys know? How much? Like a little bungalow, 2-bedroom house, maybe the one you live in, I don't know. You guys know what the square footage of a house would be?
1,000.
About 1,000, yeah. 900 to 1,000 is a smaller 2-bedroom house. This 452, now it's round, so you can't use the corners, right? Like, there's no corners. But that's like half the size of a small house. Because it's 24 feet across diameter-wise. That's a big teepee. Like, it doesn't say a teepee, but I mean, it's a big cone. It would be like a huge teepee, right? Find the cone's lateral surface. Now that's the tarp, if you were talking about. Because I use teepee just because it's the easiest to think of. You actually do take that apart, right? And you know how that's shaped. Find the area of the cone's lateral surface. So we got to use that new formula, pi rs. And I use green, I think. Yeah. A is equal to pi radius and slant height. 3.14. Radius is 12 feet. I use my color coding so you can see where I get the numbers from. Nope, it's just 12 feet in the pi rs, because it's the only feet, or it's just a plain old r, if you want to think of it that way. And then 15 feet for the slant height. But we're going to get an answer in squares. You know why? Because you got a foot times a foot, like feet twice. That's feet squared. I'm sure you're going to get this. It'll be larger than the other one. 500-ish maybe? I don't know. Okay. I know. 565.2. You're a treat, kid. 565.2. You know what though? You could do it in your head if you practice it. Feet squared. I've cut this one down into little chunks, right? Now, add those two areas for the total surface area. 452 plus the 565, and you've got it. Come in. Kid, you're all right. Check my math out because I'm doing it by hand. 1017 though, I heard you say that, right? Units? Feet squared. Feet stink? Nope, feet squared. It's good to see you. Were you the only one coming? There was somebody in the hall?
Oh yeah, we were looking for Ed.
Okay, oh, but not a student for here. Welcome aboard, Tia. As in Aaron Bird, he's back at school now? Good to have him in here, yeah. No, would be. He's supposed to be.
Well,
You told him I wouldn't yell at him, right? I'll go see. I'm gonna just stop the recording here.